Hello friends, this is 7th lecture on applications of derivative. I will explain 10 examples on derivative as a rate measure. Now, first of all, some formulas. These are the formulas for the equation of the tangents and the normal. We have completed the 50 examples on these topics, and this is the derivative as a rate measure. If y is a function of x, then dy by dx represent the rate of change of y with respect to x. If x is equals to f of t, then dx upon dt represent rate at which x changes where t is time. Let displacement s of a particle be a function of time t, then the velocity v is equals to ds upon dt and the acceleration is equals to dv by dt. But also we have the acceleration dv by dt can be written as by using the chain rule dv by ds into ds upon dt. ds upon dt is nothing but v, and hence acceleration can be written as v into dv by ds, and hence acceleration is equals to dv by dt is equals to v into dv upon ds. Now let us start the problems. A particle moving in a straight line so that s is equals to in the root of t, then its acceleration is a proportional to v raised to n, where n is equals to first option A 1, B 3 by 2, C is 3 and D is 2. Okay, now see this here. We have given the displacement s is equals to root of t. First differentiation, it's a velocity. ds upon dt is equals to 1 upon 2 times root t, that is 1 upon 2 into t raised to minus 1 upon t. Second differentiation, acceleration dv by dt is equals to, that is equals to 1 upon 2 minus 1 upon 2 into t raised to minus 3 by 2, and this is nothing but that is a minus 2 into v raised to 3, because the value of v is equals to, that is 1 upon 2 into t raised to minus 1 upon 2, and hence it becomes minus 2 into v raised to 3, and hence the value of, that is n is equals to 3. Okay, हे आपण या प्रकारे ते सिम्प्लिफिकेशन इथे करू शकतो. Hence the option C is correct here. Next, the speed v of a particle moving along a straight line is given by a plus b into v square is equals to x square, where x is its a distance from the origin. The acceleration of the particle is, first is bx, second option is x upon a, third option is x upon b, and the last option D is x upon a into b. Now the solution. Okay, we want to find out the acceleration. Here the acceleration can be written as, that is the v into dv by dx by using the chain rule. Therefore v is as it is, dv by dx, differentiate this with respect to x, then you will have, that is a 2bv into dv by dx is equals to 2 times x, 2 to get cancelled, and then you will have, that is a dv by dx is equals to x upon bv ही value मिळेल तुम्हाला. Okay, and substitute, that is the v into x upon bv, vv get cancelled, therefore acceleration is equals to x upon b. Okay, and hence the option C is correct here. Next example, the distance described by a particle is given by s is equals to a into e raised to t plus b upon e raised to t. Then the acceleration of the particle at time t is proportional to t, proportional to v, and third option is a s, and last option is theta. Okay, now see this here. We have given the distance s is equals to a into e raised to t plus b upon e raised to t, can be written as a into e raised to t plus b into e raised to minus t. Differentiate this with respect to t. Therefore, velocity is equals to ds upon dt, a into derivative of e raised to t is e raised to t. Derivative of e raised to minus t is a minus b into e raised to minus t. Okay. What about the acceleration? पुन्हा हे differentiate करणार. Then you will have a into e raised to t. Again the derivative of e raised to minus t is a minus e raised to minus t. This minus and minus that will become plus. And this is nothing but the displacement. Okay. And hence the acceleration of the particle at time t is s. Okay. And hence option C is a correct here. Next question. A particle is moving in a straight line and given by the law S is equals to at square plus bt plus 6, it is known that the particle comes to rest after 4 seconds at a distance of 16 meters from the starting position. Then the retardation in meter per second square is, okay, first option A is a minus 1, B is a 5 by 4, C is minus 1 upon 2 and D is a minus 5 by 4. Okay. तर या ठिकाणी मायनसच त्याचा आन्सर असणार आहे. ओके, नाउ विल सी दिस हियर. S is equals to at square plus bt plus 6. The velocity, differentiate this with respect to t, then you will have derivative of at square is a 2at, derivative of bt is a b, derivative of 6 is 0. What about the acceleration? पुन्हा हे differentiate करणार. Derivative of t is 1, therefore acceleration f is equals to 2a, derivative of p is a 0. Okay. Now the next, it is given that at time t is equals to 4, that particles comes to rest, means its velocity is a 0. Therefore, we will substitute here, that is a 0 is equals to, substitute here t is equals to 4. Therefore, you will have 8a plus b is equals to 0. And also at t is equals to 4, what about the distance? It covers the distance 16 meters. म्हणून या इक्वेशन मध्ये काय करणार आपण, तर t is equals to 4 substitute करणार, that is a 16a plus 4b plus 6 is equals to 16. Okay, आणि ते नंतर simplification करणार, 16a plus 4b is equals to 10. This is the equation number 2, equation number 1. And solving these two equation, then you will have the value a is equals to minus 5 by 8. Okay. What about the retardation? आपल्याला acceleration त्याने दिलेलं आहे, that is f is equals to 2a. Substitute the value of a, which is minus 5 by 8 into 2. Then you will have retardation is equals to minus 5 by 4. And hence option D हा या ठिकाणी कसा आहे तर तो correct आहे. Next question. A ball is thrown vertically upward, falls back on the ground after 6 seconds. Assuming that the equation of the motion is of the form S is equals to ut minus 4.9 t square, where S is in meter, t is in second, then the velocity at t is equals to 0 is 0 meter per second, 1 meter per second, C is at 29.4 meter per second, and D is 58.8 meter per second. Now see this here. S is equals to, we have the equation, S is equals to ut minus 4.9 t square, differentiate this with respect to t, ds upon dt is equals to u minus 4.9 t. Okay, the particle takes 6 seconds to fall back on the ground level. म्हणून त्याला जायला किती लागणार तर 3 सेकंद. It takes the 3 seconds to reach maximum height when v is equals to 0. जेव्हा तो मॅक्झिमम हाईटला असेल त्याचा वेलॉसिटी किती असेल तर तो 0 असेल. Therefore, if we substitute the value of t is 3, then its velocity is a 0. Therefore, u minus 9.8 into t is equals to 0 at t is equals to 3. Therefore, u minus 9.8 into 3 is equals to 0. And then you will have the value u is equals to 29.4. And this is the velocity when the time t is equals to 0. What about the u? U is the initial velocity when the time t is equals to 0. And hence option C हा या ठिकाणी कसा आहे तर तो correct आहे. Next example. A missile fired from the ground level rises x meter vertically upward in t second, where x is equals to 100t minus 25 upon 2 into t square. The maximum height reached is, okay, maximum height आपल्याला find out करायचे when its velocity will be 0. X is equals to 100t minus 25 upon 2 into t square. This is the first expression. Its velocity dx upon dt is equals to 100 minus 25 into t. At maximum height v is equals to 0. Okay. If we substitute v is equals to 0, म्हणजे काय मिळेल आपल्याला 100 minus 25t is equals to 0. Therefore t is equals to 4. Okay. At the time t is equals to 4, in equation number 1 we want to find out the maximum height. Okay, therefore x is equals to 100 into 4 minus 25 by 2 into t square means what, 16, and after simplification x is equals to 200. Okay, and hence option D हा या ठिकाणी कसा आहे तर तो करेक्ट आहे. Next example, if the displacement x at a time t is x is equals to in root of 1 plus t square, then acceleration is first option x raised to minus 1, second x raised to minus 2, third x raised to minus 3, and last d is x raised to 3. काय फाइंड आउट करायचं तर आपल्याला ॲक्सिलरेशन दोन वेळा त्याचं डिफरन्शिएट करावं लागणार आहे. x इज इक्वल्स टू इन रूट ऑफ 1 प्लस टी स्क्वेअर, डिफरन्शिएट दिस विथ रेस्पेक्ट टू t, dx upon dt is equals to 1 upon 2 times in root of 1 plus t square into derivative of 1 plus t square is a 2t. 2 get cancelled, then you will have t upon in root of 1 plus t square. Again differentiate this with respect to t using the quotient rule. Therefore in root of 1 plus t square into derivative of t is 1 minus t into derivative of root of 1 plus t square. It's a 1 upon 2 times in root of 1 plus t square into derivative of 1 plus t square is a 2t. 2 get cancelled upon v square means what, in root of 1 plus t square bracket square, and after simplification a simplification करना in root of 1 plus t square minus t into इथे t square ना 2 cancel होना, t square upon in root of 1 plus t square, यानी या रूट ने याला मल्टीप्लाई करना, you will get 1 plus t square minus t square upon root of 1 plus t square into 1 plus t square bracket is to 3 by 2 plus t square minus t square get cancelled, then you will have 1 upon in bracket 1 plus t square raised to 3 by 2. But what is the value of this x is equals to in root of 1 plus t square means what, 1 upon x raised to 3, that is equals to x raised to minus 3. मग आपल्याला आन्सर कसं आहे तर या फॉर्म मध्ये दिलंय, therefore ऑप्शन सी या ठिकाणी कसं आहे तर तो करेक्ट आहे. नेक्स्ट एक्झाम्पल, if s is equals to 2t cube minus 4t square plus 12t, then the distance traveled during the time interval 0 to 2 is, first option A is 56 unit, B is 24 units, C is 12 units, and D is 25 units. Okay, now the distance travel is equals to distance travel at t is equals to 2 minus distance travel at t is equals to 0. For in first case substitute, replace this t by 2, 2 raised to 3 means what, 8 into 2 you will have 16. In second case t raised to 2 means what, 4 into 4 that is a 16, and the last is 12 into 2 24 minus, and in second case replace here t by 0, then you will have here 0 plus 16 minus 16 get cancelled, therefore the distance traveled during the time interval 0 to 2 is 24 units, and therefore the option B हा या ठिकाणी कसा आहे तर तो करेक्ट आहे. Next example, if a particle moving along a line follow the law s is equals to in root of 1 plus t, then the acceleration is a proportional to square of the velocity, cube of the displacement, cube of the velocity, and last is a constant. म्हणजे आपल्याला दोन वेळा त्याचं डिफरन्शिएशन करावं लागणार. s is equals to in root of 1 plus t, therefore its velocity v is equals to ds upon dt is equals to 1 upon 2 times in root of 1 plus t. Acceleration dv by dt is equals to, पुन्हा याचं डिफरन्शिएशन 1 upon 2 ddt of 1 plus t raised to minus 1 upon t, that is 1 upon 2 minus 1 upon 2, and it's a derivative t plus 1 bracket is to minus 3 by 2. पुन्हा ते या प्रकारे आपण सिम्प्लिफिकेशन करणार, मायनस 1 by 4 in bracket t plus 1 bracket is to 1 upon 2 raised to 3. Okay, and this is the value of, आता इथे हा divided by 2 या ठिकाणी multiplied होणार, that is you will have the minus 1 upon 2 in bracket 2v bracket raised to 3. Okay, and hence the acceleration is directly proportional to the cube of the velocity. Okay, and hence the option C हा या ठिकाणी कसा होता correct. Option C is correct here. Now the next example, if s is equals to 90 minus 1 upon 3 t cube, then the particle comes to rest after first, second, third, and fourth. Okay, now see this here. We have s is equals to 90 minus 1 upon 3 t cube. Okay, differentiate this with respect to t. The particle comes to rest म्हणजे त्याचा velocity हा 0 झाला पाहिजे, म्हणून ds upon dt equals to आपण 0 करणार. याचा डिफरन्शिएशन किती येणार, तर फर्स्ट इज 9 1 by 3 t cube चा डेरिव्हेटिव्ह, that is a 3 upon 3 t square, means what, you will have t square only, that is a, it's a ds upon dt, means what, v is equals to 9 minus t square. तो रेस्ट ला आला पाहिजे म्हणजे त्याचा velocity 0, then you will have the t square minus 9 is equals to 0, त्याचे factors t minus 3 into t plus 3, t is equals to 3 or t is equals to minus 3. Okay, then you will have the t is equals to 3, and therefore the option C हा या ठिकाणी कसा आहे तर तो correct आहे. And in this way we have completed here 10 examples. Applications of derivative वर मी 225 एक्झाम्पल्स घेणार आहे. यापूर्वीच डेरिव्हेटिव्हवर 300 एक्झाम्पल्स मी कंप्लीट केलेले. डेरिव्हेटिव्हवरती एक टेस्ट पण टाकलेली आहे. तुम्ही आय बटन जर या व्हिडिओचा क्लिक केलं, देन यू विल गेट दी ऑल माय व्हिडिओ फॉर दी MHT-CET.